Problem-based learning, or PBL for short, is an educational approach that is collaborative and built around solving a complex real-life problem or scenario that you might come across in professional setting. Problem-based learning traces its roots back to the field of medicine at McMaster University, where it was pioneered by a visionary named Barrows. After his success, the applicability of PBL extended far beyond medicine, reaching fields such as law, nursing, and business. From 1980s onwards, PBL implementations were primarily conducted by individual teachers in teacher education. Since then, it has permeated our education system, with universities like Maastricht even launching a 7-step approach to incorporate PBL into their curriculum. It has also found a home in various teacher education programs at institutions like Rutgers University and the University of Wisconsin. Now, in traditional teaching, there's a teacher who stands in front of a big group of students and gives a lecture, while the students scramble to listen, understand, and remember everything the teacher is saying. It can be hard to keep track of all that new information, let alone really absorb it. In contrast, problem-based learning is designed to teach students how to teach themselves while becoming master problem solvers along the way. The classroom looks like this. A handful of students work in small groups, exploring real-life scenarios with the guidance of a tutor. Problem-based learning is often used in medical studies, where students work through clinical cases, but its adaptability makes it so flexible so it can easily be implemented to other fields such as architecture, design, and the others, where students work on real-life projects. For instance, let's imagine that our problem-based learning case presents a scenario where a local community needs a sustainable, affordable housing solutions. The student architects start thinking about this problem by brainstorming a list of questions. What are the specific needs of the community? What is the local climate like? What are the available local materials? What are the budget constraints? Could the solution involve solar power, rainwater harvesting, or other co-friendly methods? Over the course of the session, the case might include community surveys, local zoning laws, building codes, and even interactions with real community representatives who can answer their questions. Together, the students figure out what they already know and where they might have gaps in their knowledge. Their questions open up new paths of inquiry, quickly evolving into a complex web of knowledge and further questions. All of the information in these questions are tracked by a student, scribed either on a whiteboard or a shared document online. Many groups also create mind maps to organize their thoughts and untangle the web, which helps mirror how our brains work to construct knowledge. So while students are asking questions about the problem, creating and untangling information, where's a tutor? What is their job? Well, the tutor supports self-directed learning by facilitating the process, generally staying in the background and strategically directing the discussion to get students to dig deeper into the material. The tutor also helps to make sure that everyone is participating, collaborating, and thinking critically about the problem. Rarely do tutors provide actual information. At the end of the discussion, the group makes a list of learning issues, the how and why questions that need to be researched before the next session. For our community housing project, the group might research: how exactly does solar power work? Why is affordable housing a critical issue? Students divide up the list of learning issues and head off to research on their own. Now, before the next class, each student gathers information from online resources and books and shares it with the rest of the group. That's why, when the students meet up again, they can dive right in and apply the new information to the case. This critical step provides students with the opportunity to weave individual concepts together to get a deeper and richer understanding of the material by putting it into a larger conceptual framework of the case and our web, which becomes stronger, more organized, and more easily remembered. The case might be revealed in a single day or over several sessions. Either way, students continue to build and iterate on their knowledge webs and applying what they learned and clarifying anything that's unclear. By actively engaging in learning through problem solving, students do more than memorize content. They also learn how to work together to build a strong web of interconnected information, which they use to solve real-world problems. Additionally, students master meaningful skills like teamwork, critical thinking, lifelong learning, and communication. All right, as a quick recap, through problem-based learning, students can examine cases or problems, follow their curiosity to answer specific questions that come up as they explore, and collaborate with their group to share and learn information. In this way, they can actively construct complex webs of knowledge, which help them remember the information that they use to solve this problem and the next one.